5.3.3a, if u of z equals 2e to the 2z times the square root of z, then when I read this function, I see 2 times e to the 2z times the square root of z. There are z's located both in the e to the 2z and the square root of z. There's not a z over here with the 2. But for sure, I do have two separate functions times each other. I'm going to need my product rule. Now, because there's no z over here with the 2, I can group the 2 with either the e to the 2z or the square root of z. The product rule says if we have f times g and we want to take the derivative, it's the left times the derivative of the right plus the right times the derivative of left. F g prime plus g f prime. I used to have a friend that would make it kind of sing-songy. He'd go, it's left d right plus right d left. Okay, so when I go to take that derivative, I'm going to call the left the 2e to the 2z, and the right I'm going to write as z to the 1/2, so that I have it looking like something I could use a power rule on. The derivative of 2e to the 2z uses a little bit of a chain rule, right? It's a little tiny one. I bring the 2 down because of the constant multiple rule, and the derivative of e to the stuff is e to the stuff times the derivative of the stuff. So this time that is just 2. 2 is the derivative of 2z. The derivative of z to the 1/2 is going to be 1/2 z to the negative 1/2 because of the power rule. Next, I want to put this together with my product rule. And the product rule says I do the left, which is the 2e to the 2z, times the derivative of the right, which is the 1/2 z to the negative 1/2, plus the right, which is the z to the 1/2, times the derivative of the left, which is 2e to the 2z times 2. Okay, now that we have all the pieces of this together, let's see if we can simplify it a little bit. So this is left d right plus right d left. Okay. Well, I do for sure see some things that can cancel or simplify. Right? We see, well, let me make it all the same color again. I see a 2 and a 1/2 right here. Those can cancel. So let me just take those away. And then I also see a 2 on the right side, and a 2 would multiply together and give me a 4. So I make that a 4 and take this 2 away. All right, and then last but not least, I could write this z to the 1/2 back into a square root, and I could move this z to the negative 1/2 into the denominator of the e to the 2z. So I could actually say that this is equal to e to the 2z and then divided by the square root of z. And then plus 4e to the 2z times the square root of z. Okay, so this is ultimately what I'm looking for here. E to the 2z over the square root of z plus 4e to the 2z times the square root of z. All right, so I know choice A has way too many terms, right? I have some stuff plus some other stuff plus some other stuff. Definitely that A is not it. Similarly, B has too little stuff, right? I don't have a plus at all. I have no second term on B. C might be a possibility. It has the right number of terms, just glancing at it. Does it have all the right stuff? Let's see. I've got e to the 2z on top, square root of z on the bottom, plus 4 e to the 2z, square root of z. Yes. So it's definitely going to be choice C. Let's just look at D to make sure. Yeah, Z's got the minus, and I didn't really have any minuses anywhere other than I had that negative 1/2 there, but that was a power. So don't discount it immediately just glancing at it because it's a minus, because it's possible you could have had a negative in your problem somewhere that would be rewritten as a minus, but certainly it does not seem to match up in our problem, right? Plus we would have this 2 times 2, and then divided by 2 would give me a 2 somewhere. I do not have any 2's for coefficients there, so yeah, choice C is the right answer.